Today our topic is Tanker Numericals for phase 1, which is coming for the 25 marks and it's compulsory question. So by watching this video you can able to solve any type of numericals. We'll select 8 different type of numericals so that you will able to understand all the type and different times, and so you will solve any type of numerical which is coming in the MMD exams. So before proceeding to the numericals, we go through some terminology which the tanker guys already know, but for the non-tanker guys it's something it's little bit they feel not comfortable with that. So before going to numerical parts we have to discuss this some terminology so that they will also on the same page. Okay, so once the vessel go on loading port, so the surveyor will come and check all the tanks, and they find the OBQ, means after discharging your cargo, when you transit and you come on the load port, so there is because of some vibration, pounding, the remaining sludge, the crude oil or sludge, remaining oil will deposit on the top of the tanks, so it will become OBQ. So they will check and find out the quantity, how much OBQ you have. So this is the quantity of cargo in the ship tanks before loading. So before loading, when the surveyor check, they found some quantity of oil, sludge, whatever, that declare the OBQ, onboard quantity. So OBQ may be either liquid or non-liquid. During the ballast voyage, the oil sludge cleaning on the sides collect to the bottom of the tanks. Hence the OBQ on arrival load port may be little more than ROB after last discharge. So what is ROB? When the vessel discharging at the discharge port, after a certain discharging, there is a pump loose section which is unpumpable to discharge. Okay, so that after discharging empty the tanks, how much remaining of oil, that is called ROB. So ROB is for discharge port and OBQ is for load port. So ROB is remaining on board. This is the quantity of cargo that is remain in the ship the tanks after discharge. ROB may be either liquid or non-liquid. It might be slightly sludge because some crude oil tanker is little thick cargo. So because of maybe sludge deposit or something. Now let's see ullage, which is ullage and sounding is most important in the numericals. So ullage is a empty or it is wide space between the surface of the liquid to the top of the tanks. So you can consider a half glass of water. So if you see from the top, from the top the glass and where is the what level of water, the free space is called ullage. And if you put the one measurement, you can put one scale, it will go to the bottom of the glass and measure up to the water level. It is called sounding. Okay, so let's discuss. Ullage is a void space, or void space means empty space between the surface of the liquid to the top of the tanks, and sounding, it is a height from the bottom of the tank to the upper surface of the liquid. So let's see example. Now you can consider this is a glass of water. So when you see the red line, see in the top of the tank to the water level, it is called ullage, and from this blue line to the bottom of the tank, this call is sounding, and this wide space is called, or empty space is called, ullage. So this is very important. And you know this water cut or oil dip, the density of oil is lesser than the water, so it will float on the top of the waters. So let's see, if you load the cargo till here, but during the survey they found this water cut, that means water is up to this mark. So this is a water cut or oil dip. Now the same things, what ullage and the soundings. Same here, it is called ullage and this is called sounding, and this is called deep water level. So how onboard, how they will detect? They have one UTI tape MMC sensor. So once they touch and the water interface level change, it will give the some tune, different tunes. Okay, so now the how to calculate, some terminology to calculate. Depth of the oil is equal to height of the top of the ullage pipe to the tank bottom minus corrected ullage. Okay, if the vessel is upright and even keel, you no need to apply anything, no least correction, no trim correction. But it's not possible, maybe by either slightly vessel, little bit trim, little bit laced. Okay, so we have to put we have to use corrected ullage. So to find out the corrected, main basic funda is to find out the correct ullage in the phase 1 questions. Okay, so GOV, gross oil volume or gross observed volume. When you observe with the temperature, it will gross observed volume or gross oil volume. Okay, so GOV at required temperature is equal to length and breadth of the tank into depth of the oil. So length of the tank, breadth of the tank, and the depth of the oil, that means sounding of the oil. Volume correction factor. Volume correction factor we get from the ASTM, American Standard of Testing and Material. There is one booklet, so from there we get table 54. Sometimes they give the volume correction factor in API or sometime in 15 degree density. So we also see that type of numerical when we do the past paper solution. Okay, gross standard volume, GSV. GSV is equal to GOV into VCF. GOV we get the observed, and the VCF we get from the ASTM table. So after multiplication we get the net observed volume. So net observed volume, then weight reduction factor, WRF is equal to specific gravity minus 0.0011. This is standard. Okay, so now quantity of oil at 15 degrees is equal to net observed volume into weight reduction factor. So we get the quantity in tons. Now mass is equal to density into volume, or we can say the density is equal to mass upon volume. So mass is equal to density into volume. So mass of oil does not change with temperature, it will remain constant. So that's why when we give the figures quantity, we use the mass. Density, density varies with the temperature. So in temperature increase, density reduce, and temperature decrease, density increased. Okay, inversely proportional to the temperature. Volume, temperature increase, volume increase, it is directly proportional to the temperature. So this is a vessel, little bit trim by stern. Okay, now this is the normal, you can say normal things in the tankers. Now for the onboard, now we are doing all this on the lodicator, but for a point of a MMD exam view, we have to calculate for 25 marks to clear the phase 1 exam. So when ullage is taken by, okay, so when ullage is there is 3 formula which is very simple. I will show you all 3 formulas. You all learn 3 formulas and you finish your cargo oil tanker numericals. Okay, so first is when ullage is taken by, if the question is given when the ullage is taken by anyone, ullage tape, sonic tape, MMC and UTI, this tape which is manually we can do. So if we do this, that means we are going to use this one formula. So now you consider this is your tank A, B, C, D. Okay, this is your tank and vessel is trim by stern. Okay, so this is distance from the aft bulkhead, this U, this is ullage point above the top of the tanks. So UV is your observed ullage, whatever you observe by the tape. Okay, and UP is corrected ullage for tape, TP is corrected for trim, UT is ullage corrected for tape and trim, CD is the length of the tank, BC is the breadth of the tank, A is the distance between the ullage pipe, on board the location of ullage pipe where we measured, okay, that is distance A. And transfer distance with respect to center line, how far away from the center line, so that is called B, transfer distance of ullage pipe from center line. Now the first formula is, when the question comes ullage collected for tape, trim and list, so we use this formula: observed ullage into sec into tan inverse trim by LBP plus minus L by 2 minus A into trim by LBP plus minus B tan theta. Now see, if the question say vessel is upright, so we have to use only this one formula, okay, this much only. If the question also have some trim, then we have to use till the, okay. And when we have list, we also use this red one. So you remember this one single formula, and when as per question you will subtract, okay. So that means this is trim formula, this is list formula, and this is tape formula, okay. And how do you decide positive or negative between the trim, okay? If the ullage pipe towards the trim in, that means if your vessel stern, trim by stern, and your ullage is in the stern side, aft side, so that means it will positive. And if it is like your trim by stern and your ullage is to forward side of the ullage, so that means it will negative. The same is with the list also. Positive if ullage pipe towards the list side, that means if your vessel is on port side list and your ullage location where you are taking from the ullage, it is also the port side with respect to the center line, that you will be positive. And if it is opposite side, that means if your vessel is list on the port side and your the location of ullage point is starboard side, then mean we have to subtract, okay. So understand this ullage collected for tape, trim and list formula, and the plus minus sign how to use, okay. When the ullage is taken by the radar beam, now see, on tankers every hour we check the figures, that is called ship shore figures, so that we know that there is not so much difference. This is also for pollution. If the oil is the discharge, oil will receive, that means it's not going to anywhere, so directly coming from there and we receiving. So it is not possible every tanks, because now 15-16 tanks, so every hour you cannot check the by UTI, so we have the fitted system, that is called radar beam gauge, so it will give the readings directly in the CCR cargo control rooms. So but before one or two times we can just figure out which the manual and with the what is showing in the radar beams, we can cross verify it, okay, on board practical wise. So now if the question say your ullage was given by the tank radar beams, so the formula will little change, okay. The formula is UP, okay. So for remember you can say UP, Baba Yogi Adityanath, plus minus L by 2 minus A into trim by LBP plus minus B into tan theta. So there is only change is UP, okay. This is trim formula, this is list formula, which already we used when the tank radar gauge, tank UTI MMT, the same formula. So you just remember when the radar beam use, we just add Uttar Pradesh, UP, okay. So this is simple way to remember, because we cannot remember each and everything. Easy for the tanker guys, but for non-tanker guys little bit difficult. So just remember like this way, or you can choose whatever you buy. Now wedge calculation, okay. The tank is not like a horizon, or it is not like an empty space, because of forward and aft there is little bit sloping the tanks, so there little bit, when checking the radar, when checking the ullage, it will be not exactly, so that is called wedge calculation, okay. So we have to figure out how much wedge calculation. If you see this diagram, you see the OL, this is OL, this oil deep water cut sounding, whatever you want to say, whatever question say you can use. UP, height from the top of the ullage pipe to the tank of the bottoms. Theta is equal to trim angle. A is equal to distance between bulkhead and ullage pipe, which we used previous also. GD is the height of wedge, so GD is height of wedge, and BC is the DH is the base of the wedge. Okay, so formula you have to just remember this. How you will remember this formula? Okay, so in the wedge calculation, always given is UP. Okay, UP given and OL is given. These two things we have already known. We have to first find this UO. Okay, first we have to find UO. So to find, we have to first find UL. Okay, this one we have to first find out UL. So UL is equal to UP, it is parallel to this, no? So UP into sec tan inverse trim by LPP. Okay, once we know UL and we know OL, so we get UO. Okay, by subtracting. Now once we know UO, this one, we can get UT. Okay, the same formula which you use for UL, UO into sec into tan inverse trim by LBP. Once we know UT and we know the UP, we get the TP, correct, by minus. Then when we know TP, we can use the formula and we can calculate the pH, this pH. Okay, so for pH is equal to TP into LBP by trim. We in this about two numerical we use trim by LBP, so just put the opposite, LBP by trim, and remove the sec and tan inverse, so the formula becomes simple. Okay, now DH is equal to A plus PH, so this is DH, and from here to here it is A, so A plus PH is equal to DH. Okay, so if DH is less than CD, CD is your length of the tank. Okay, if your DH is less than CD, then only wedge is formed, then only we use the wedge calculation formula. Otherwise no need to calculate, we directly use the if ullage was corrected by trap, trim or list, we use that formula. If the radar is that, we use that formula. Okay, once we know that vessel is wedge, so we have to calculate this area of wedge and volume of wedge. So area of wedge is looks like triangle, so we calculate GDH triangle 1/2 base into height. But before we have to calculate height also, that is called GD. So GD is equal to DH into trim by LBP. Okay, so volume of wedge is equal to area of GDH into breadth of the tanks. So this is all three basic formula to use when using the numericals. So let's start numericals. The first numerical is an oil tanker measure was 32 m, 20 m and 19 mm, 19 meters. So this is the area of the tanks, length into breadth into height. On arrival port, the 3.2 ullage was observed by the sonic tape. That means it is observed ullage, because you are using sonic tape. Manually you are going to see this ullage. From the ullage port located, the location of the ullage port is given, which we use in the formula. 4 meter forward of the after bulkhead, 3 meter to port of the side of the center line, 1.8 meter above the top of the tank, length between perpendiculars 288 meters, trim 3.5 meter by head, vessel down by head, list 4 degree to port, cargo temperature was 31.5 degree centigrade, Okay, so after the lighterage, that means vessel is coming from the lighterage, so there is some cargo discharge. Lighterage means discharging to reduce the draft. So cargo temperature was 27 degree after lighterage. Ullage was 14.22 measured by the radar, tank radar, which was located 4 meter to port of the center line, 9 meter forward of the after bulkhead, and 92 centimeters. So just see here, it is 92 centimeters. So it's only given for the confusing. Okay, so all the units should be in meters, so you have to convert in meters also. Above the top of the tank, trim 2 meter by Astem, list 3 degree to starboard. If oil density is vacuum at 15 degree centigrade is 0.8331. Find the quantity of cargo discharge. So there is two calculation. One is before the lighterage and after the lighterage, so that we can find out the figure how much quantity discharge. And the two formula we are going to use, because first time when the ullage was measured, it was by sonic tape, that means first formula, and during the second time it was measured by the radar gauge, so that second formula we use. So the two formula we are going to use here. Okay, so in the exam when you do, so first you will write what is given in the question, so that it will give the good impression to the examiner who will going to check your papers. Okay, so whatever given in the question, just write down. So you can say, I give you one example for this numerical. On arrival, tank was 32 into 20 into 19. Okay, ullage 3.22 meter by sonic tape. This is also very helpful for you when you are solving the numericals. Then you write location of ullage port. So just write 4 meter forward of the after bulkhead, 3 meter to port, side of center line, and 1.82 meter above the top of the tank. LBP 288, initial trim 3.5 meter by head, and list was 4 degree to port. Cargo temperature 31.5 degree centigrade. Okay, this is first part. After lighterage, cargo temperature 27 degree centigrade, ullage 14.22 meter by tank radar. Location of ullage, four meter to port of center line, 9 meter forward of the after bulkhead, and 92 centimeters, which we convert in meters, above the top of the tank. Trim 2 meter by stern, and list 3 degree to starboard. Density in vacuum at 15 degree centigrade is 0.8311. Find out quantity of cargo discharge. So if you write like this, the examiner who is going to check your paper, he will impressed because you understand the question. Okay, so that's why you have to, and this will also take one page, half page of paper. So 25 marks you have to cover at least 3 page, no? Okay, so now we are going to solve. Okay, so vessel trim by head. Okay, put the name A, B, C, D. So this is your length. So length is given 32 mm, 32 meters, and your, if you say this is breadth, so breadth is given is 20, and your height is given 19 meters. Okay, the Ullage was measured sonic tape. Ullage port located is 4 meter forward of the aft bulkhead. This is the location of your Ullage port. So it is 4 meter from the aft bulkhead. That is called A. 3 meter to port of the center line. So if this is your center line, so it's starboard port. So 3 meter to port. And 1.82, that means from the top of the tank 1.82, it is top of the tank. Okay, so let's calculation. This diagram you understand? Okay. Now let's solve. So first is using by the radar sonic tape, no? So we use the first formula. Okay, so Ullage corrected by tape, trim and list, because all three covers tape, trim, list, no? So we are going to use the same formula. The formula is U into sec tan inverse trim by LBP plus minus L by 2 minus A into trim by LBP. This is trim formula. Now list formula plus minus B tan theta. So observed Ullage was 3.22. Okay, into sec tan inverse trim, initial trim was 3.5, LBP 288. Now the vessel down by head, and your location of the Ullage is 4 meter forward of the aft bulkhead. Don't confuse the forward, forward of the aft bulkhead. That means this is aft bulkhead, so 4 meter forward, 4 meter forward of the aft bulkhead. So it is behind only, and your vessel is down by head. Okay, so it is only in location of aft, so it is opposite, so it will sign the minus. So length is 32, it is given in the questions, divided by 2 minus A is 4 meters into trim 3.8 divided by 288 LBP. Now the vessel was 4 degree to list was 4 degree east, and the 3 meter to port of the center line. So same side, list is also port side and the location of the ullage pipe is also port side, so it will be plus 3 10 4 degrees. Okay, after you solving you will get the value 3.284. okay, or 3.22 minus 0.1458 plus 0.209. so after that we get the value 3.283. so right after decimal 3 digit. Now this is corrected ullage. We have to find the depth of the oil. So depth of the oil is equal to, or you can say height of oil. This is, if you see, this is ullage. We calculate this one, but we don't need this one because we require this one, no, volume of oil. So which get from the soundings. So you can say sounding also. Okay. So how we will get from the total height, from this height to minus ullage, this height. If we know this height total and we subtract this height, so we get the, okay, is equal to ullage height of top of ullage pipe to the bottom of tank minus corrected ullage. Corrected ullage we calculate here. So height is 19 meter plus we have 1.84 which is top of the tanks. Okay, so we use that one also. So 1.82 and we minus corrected ullage 3.284. so we get the 17.536 meter. Now this is volume, so you can say sounding of oil. Okay, depth of the oil, whatever you want to say. Now so volume of oil in the tanks, we get the 32 into 22. Length breadth is the same and we use this 17.536 and we get 11223.68 meter cube volume of oil. Okay, so this is called GOV, gross observed volume, 11223.68 meter cube. Now we use VCF at 31.5 degree when we use Astem table 54 and we get the value 0.9862. Okay, now we find net absorbed volume at 15 degrees temperature pe. So that is GOV into VCF, 31.5 degrees centigrade. Okay, so we get 11223.68 into 0.9862, 11068.79 meter cube. Okay, this is net absorbed volume at 15 degree temperature. Now we find the quantity. So quantity is for weight reduction factor. Weight is specific gravity minus 0.0011, which is universal. So given is 0.8311 in the question, 0.0011. So we get 0.83 weight reduction factor. So quantity, or you can say mass, or you can say quantity of oil is equal to 11068.79, which is net absorbed volume into weight reduction factor into 0.83. So we get the value 9187.09 tons. It is come in tons. Now the first part of the question is clear. Now we are moving on the second part of question. Okay, after lightrage. when after laterage, when we check the ullage by radar gauge. So we use the radar gauge formula here. So first I will draw this diagram. While second time the vessel trim by stern. Okay, and vessel trim by stern. Okay, so we are going to use the second formula. Ullage corrected for tape. No. Ullage corrected for trim and list. UT is equal to UP plus minus L by 2 minus A into trim by LBP, which is list formula, plus minus B into 10 theta. This is list formula. Okay, so ullage was, when we measure by the radar beams, it will 14.22. okay, and the vessel trim by stern, and the radar location of the radar is also stern. So plus 32 by 2 minus 9 into 2 by 288 LBB. So it is opposite side now. Okay, so this will get the corrected ullage by radar beams. Now we have to find out the depth of the oil. So depth of the oil is equal to height of top of ullage pipe to the bottom of the tank minus corrected ullage. So 19 plus 0.92, 92 centimeters, so we convert in the meters. Okay, minus 14.059 equal to 5.86 meter. This, now we calculate gross observed volume of oil. So it's equal to 32 into 20 into 5.861 is equal to 3751.0 meter cube. Okay, volume correction factor at 27 degrees centigrade 0.9899 from ASTM tables. So we get the net observed volume at 15 degrees centigrade. This convert, we have to convert in the 15 degrees. So we'll bring on the into the 15 degree, because all the calculation, all the standard is set on the 15 degrees centigrade. So 3 net of the GOV into VCF. So 3751.0 into 0.9899. We get the net observed volume 3713.2 meter cube. Now weight reduction factor, density is given, specific gravity minus 0.0011, so it's equal to 0.8311 minus 0.0011 is equal to 0.8300. So mass is equal to net observed volume at 15 degree into weight reduction factor So 3 7 132.2 into 0.8300 is equal to 3081.9 tons. So after lighterage we get these figures, and initially we get the 9186. So quantity of cargo discharge is equal to initial 9186.6 minus after discharge the remaining one. This much quantity discharge. Okay, we'll solve the next question. Okay, so next question is a box safe cargo oil tanks 30 into 20 into 15 meters is loaded with crude oil. On completion, Ullage found by UTI tape. So first it is by UTI tape was 2.10 Ullage as 31 degrees centigrade. They found water cut also 20 centimeters. Calculate the weight of cargo in air if density at 15 degrees centigrade in vacuum is 0.880 kg per liters. LBP 210 and trim 2 meters by stern. The location of Ullage port located 3 meters forward of the aft bulkhead. Assume the reference point of Ullage is main deck. Okay, so first what is given in the question? Dimension of the tank 30 into 20 into 15 LB length, breadth and height. Okay, UTI tape Ullage 2.10 at 35 degrees centigrade. Water cut 20 cm. Convert in meters. Okay, temperature at 15 degree, density is 0.8800 kg per liter. LBP was given 210, trim 2 meter by stern. Location of Ullage what 3 meter forward of the aft bulkhead. Okay, so there is no list, so let's make the diagram. A vessel wide, trim by stern. Measure by UTI. So the first tank it is on main deck, so know about the top of the tanks, so U is will come here. So dimension of the tanks, okay, 30 meter. If you say this is breadth 20 meter and your height is 15 meter. Okay, location was Ullage port is 3 meter forward of the aft bulkhead, so this is A. Okay, so first we going to use first formula. Ullage corrected for tape and trim because there is no list, so we remove that list part of formula. Okay, so UO into sec 10 inverse trim by LBP plus minus list for trim formula, length divided by 2 minus A into trim by LBP. Put the value 2.10 into sec tan inverse trim 2 divided by LBP. So the vessel by trim by stern, and the location of the Ullage port also is the aft stern side, so it will be positive because of the same sides. If it is opposite, then it will use the minus. Okay, then 15 30 divided by 2 minus 3 into 2 by, so we get the value 2.10 plus 0.114 is equal to 2.214 meter corrected ullage. Okay, now we'll find the depth of the mixture, or we can say sounding of mixture. Formula is equal to height of top of the ullage pipe to the tank bottom minus corrected ullage. So 15 minus 2.214 is equal to 12.786. Now we find GOV. GOV is gross object volume of oil. So GOV is equal to 30 into 20 into 12.786. So we get the 7671.6 meter cube. Okay, this is first part of numericals completed. Now we find out the total quantity, but we have to remove the water so that we know the exact oil quantity. Okay, now we calculate which is mix of oil and water. Now we have to calculate water and then remove from the totals. We get the actual amount of quantity of oil. So there is fed, so we have to make that diagram also. Vessel trim by stern, this is oil cut which we have given 0.20 meters. Okay, UP is 15. Okay, so first we have to find UL. We have to find first UL, this one. So UL is equal to UP, opposite side of this one, UP into sec tan inverse trim by LBP. Okay, so 15 into sec into tan inverse 2 by 210. So we get UL is equal to 15.001 meters. Now we know UL and we have OL, so we get UO. So UO is equal to UL minus OL. OL is water cut or deep. So 15.001 minus 0.20 is equal to 14.801 meters. Now we know UO, so we can find UT. This is UT. The same formula, instead of UP we press UT. Okay, so UT is equal to UO into sec tan inverse trim by LBP. So 14.801 into sec tan inverse 2 by 210, we get 14.802 meters. So we can find TP because we know UP and UT. So UP minus UT is equal to 15 minus 14.802 is equal to 0.198 meters. We know the TP, so we can find out pH. pH is equal to TP into, before we are using trim by LBP, just remove this formula and just substitute it. So LBP by trim. So 0.198 into 210 divided by 2. So we get 20.79 meter. Now DH is equal to A plus pH. A already given in the question, 3 meters out of the bulkhead, plus we already calculated pH. So we get the DH 23.79 meters. Now DH is less than CD. CD is length of the tanks. So length of the tank is 20 meters. So DH is less than CD. So DH is 23.79 and it is less than CD. CD is a length, so 30 meter is length. So it is less than, so that means wedge is formed. So wedge is formed. So we'll move to the further. So we have to calculate the triangle. Before calculating, we need to base and height. So already we have the DH which is based. We calculate the height which is called GD. GD is equal to TH into trim by LBP. Okay, so we know the GD we calculate. Now we know the DH. DH is 23.79 into trim by LBP. So trim is 2 divided by 210. So opposite that. So we get 0.227 meters. Now we have the length and we have the height and we have the base. So we can calculate the area of triangle GDH, which is 1 by 2 base into height. Base is DH and height is GD. So 1 by 2 into 23.79 into 0.227, so we get 2.700 meters square. So volume of wedge is equal to area of triangle GDH into breadth of the tank. So 2.70 into 20, so 54 meter cube is your water cut. Okay, so we remove from the total volume. So total volume of oil and water mixture 7671.6 meter cube. Volume of water cut 54 meter cube, so minus 7617.6 meter cube. This is quantity volume of gross observed volume of oil. Now we have to calculate, this is also called GOV. Now we have to calculate VCF on the ASTM tables. So we get the 9849 at 35 degree temperature. Now we calculate the net observed volume at 15 degree temperature is equal to GOV into VCF. So 7617.6 into 0.9849. So 7502.6 meter cube. Now weight reduction factor is equal to specific gravity minus 0.0011. So 0.8800 minus 0.0011 equal to 0.8789. So quantity or mass of oil is equal to net absorbed volume at 15 degree temperature at into weight reduction factor. So 7502.6 into 0.8789. So we get the value 7595.0 tons is quantity of oil. Okay, so let's move on the third question. Now the third question is a box shaped cargo oil tank of the dimension 22 m, 18 meters and 18 meter is required to be loaded with crude oil at a temperature of 26.5 degrees centigrade if the 2% of the volume of the tank is left for the expansion. The observed ullage by the UTI tape at the ullage port, which is located 2 meters forward of the aft bulkhead, 1 meter above the deck and 3 meters the port of the center line. So the least trim and the above the term, all the three is covered. And the weight of the cargo in the air is metric tons. Given LBP trim 2.5 meter by stern, list 1 degree. Starboard side density of oil is 15 degrees centigrade in vacuum, 0.8450 kg per liter. Okay, so dimension of the tank is given. The expansion, why expansion is required? Let's consider this is your tank. Okay, then you fill 98% of oil. Generally on tanker 98% maximum we can load, because 2% we left for expansion, because during the passage when the temperature rises, the volume of the oil will increase and it will increase. So maybe oil level it come here, so that's why 2% volume of tank is left for expansion. Okay, so this is tank left for expansion. So let's see how it's solved. So first in exam you have to write whatever given. Okay, then we'll draw the diagram. So trim by stern, observed ullage theta, so this is your diagram. Okay, trim by stern, and we have the UTI, measuring the UTI tapes. So the first diagram. Now we have the height of free space. Okay, so let's solve this question. Volume of tank is equal to L length into breadth into height. So 22 into 18 into 18 is equal to 7128 meter cube. Now volume of tank, let's consider this is your volume of tank. So what is volume of tank? This is oil. So volume of tank is volume of oil. This is volume of oil and this is free space. So this is free space and this is volume of oil. So total volume of tank is equal to volume of free space plus volume of oil. Volume of a tank is equal to volume of oil plus free space. Okay, so volume of tank we calculate 7128. Volume of oil we don't know, so we just write V. Free space, now they are saying 2% volume of the tank. So 2% volume of the tank. Okay, now 7128 is equal to V plus 142.56. So therefore V is equal to 7128 minus 142.56. We get gross observed volume is 6985.44 meter cube. Okay, this is gross observed volume. Now volume correction factor at 26.5 degrees centigrade is 0.9907. So net absorbed volume at 15 degree temperature is equal to GOV into VCF. So 6985.44 into 0.9907. So 6920.47 meter cube net absorbed volume at 15 degrees centigrade. Now weight reduction factor is equal to specific gravity minus 0.0011. So 0.8450 minus 0.0011, we get 0.8439. So mass is equal to net absorbed volume at 15 degree temperature into weight reduction factor. So therefore 6920.47 into 0.8439. So we get the mass is equal to 5840.18 ton. Okay, so this is, I calculate the first is second part. Okay, metric tons. Now the observed ullage by the UTI tape at the ullage port, which was located 2 meter forward of the aft bulkhead, 1 meter above the deck and 3 meter above the port of the center line. So we have to calculate now ullage, observed ullage, not corrected ullage. So first we have to find out the corrected ullage, then we have to find the observed ullage. Okay, now we have the mass of oil. Now we can find the sounding of the oil, or we can find the corrected ullage. So corrected ullage, mass of oil divided by length into breadth of the tank. Divided by 22 into 18, so we get to 17.64. Okay, now we require height of oil soundings, no? Or we can say oil height. So total height minus corrected ullage. So 19 minus 17.64, we get 1.36 meter corrected ullage sounding. So UT is equal to UO, for put the value in the formula. So we have the corrected ullage 1.36. We have to find the observed ullage into sec tan inverse 2.5 divided by 220 plus, because this trim by Astem, and we have the aft bulkhead. Okay, so 22 by 2 minus 2, 2.5 divided by 220 minus 3, 10 1 degree. So therefore 1.36 is equal to UO into 1.000 plus 0.10227 minus 0.05236. Therefore 1.36 divided by 1.04991. So observed ullage we get 1.295 meter. Okay, when we have the mass, we can find out the sounding of the oil, and then we have to find out the ullage, which is corrected ullage. Okay, let's move the next question. Question number 4. Okay, question number 4. Using a UTI gauge from the ullage port, a box shaped cargo oil tank 20 meter into 15 meter into 11.5 meters registered an oil depth of 27 cm. So oil depth 27 cm. So we have to convert in meters. With a water cut of 10 centimeters on arrivals. So water cut also is given, just 10 centimeter. So that will also we have to convert in the meters. At a loading terminal, calculate the onboard quantity. So OBQ is on arrival. We have to check this by the surveyor how much quantity we are coming, so that they give you the exact figure how much loaded. So onboard quantity we have to remove the final loading. Okay, given 3 meter trim by stern, LBP 171.87 meters. Ullage port is located 6 meter forward of the aft bulkhead. Okay, so first it is given it oil deep. Okay, so we have to first check it is the wedge is formed or not. Okay, so first we have to find out the wedge formula. Okay, put the value name A, B, C, D, the dimension of the tank. Okay, then GH UOLTT. This is A, which is 6 meter. Okay, OL, this OL is given 27 cm, which is 0.27 meter. Okay, so total height of ullage pipe given 11.5 meters. This is 11.5 meter. LBP is given 171.87 trim by Astem and a 6 meter. So first we have to calculate the UL. We have to calculate UL. We have the UT and we have the OL. So UL is equal to UP into sec tan inverse trim by LBP. Put the value 11.5 into sec tan inverse 3 divided by 171.87 is equal to 11.502 meter. We have the UL and we have the OL, so we can find a UO. So UL minus UO is equal to 11.502 minus 0.207 is equal to 11.232 meters. Now we have the UO, we have the UP, so we can find our UT. So UT is equal to UO into sec tan inverse trim by LBP. So U is 11.232 into sec tan inverse trim is 3 divided by 171.87. So we get UT is equal to 11.234 meters. So we can find out TP, which is UP minus UT. So 11.5 minus 11.234, we get 0.266 meter. Okay, so now we can find out pH is equal to TP into opposite. Remove these things and opposite this one. LBP by trim. So 0.266 into 171.87 divided by 3. So we get 115.239 meters. Now DH is equal to A plus PH. A is given in the question 6 plus 15.239. So that is 21.239 meters. So DH is equal to 21.239 and CD is equal to 20 meters. So DH is greater than CD. So wedge is not formed. If a wedge is not formed, then we have to calculate the same things. This one is we are checking the vessel is wedge form, tank is wedge form or not. So by calculating this, we find out that it is not wedge form. So now we have to use the red UTI tape formula. Okay. So now that we have to make the other diagram. Vessel trim by Astem. Dimension of the tank. Okay, now put the value. Ullage corrected for tape, trim and list. So is equal to UO into sec 10 inverse trim by LBP plus L by 2 minus A trim by LBP plus minus B 10 theta. So is equal to 11.232 into sec 10 inverse 3 divided by 171.87 plus 20 divided by 2 minus 6 3 divided by 171.87. We don't have the list, so we have to remove this list formula. Okay, so 11.234 plus 0.070 is equal to 11.304 meters. So observed volume and water mixture is equal to 20 into 15 into 11.5 minus 11.304 is equal to 58.8 meter cube. Okay, this is mixture, both oil and water. Now we have to remove the water, so we have to find out the quantity volume of water. So to find volume of water, make another diagram. Trim by Astem. UOLPT so UL we already have 11.502 meters. So UO is equal to UL minus OL. So 11.502 minus 0.10 is equal to 11.402 meters. Now UT is equal to UO into sec 10 inverse trim by LBP. So 11.402 into sec 10 inverse 3 divided by 171.87 11.404 meters. Now TP is equal to UP minus UT is equal to 11.5 minus 11.404 is equal to 0.096 meter. Put the value pH. TP is equal to LBP by trim 0.096 into 171.87 divided by 3, so we get 5.500 meters. DH is equal to A plus PH. So A is equal to 6 given in the question and 5.500 we have calculated, so 11.500 meters. So DH is equal to 11.500, CD is equal to 20 meters. So DH is less than CD, so wedge is formed. Now we have to calculate the volume of the wedge. So before that we have to calculate the area, and before the area we have to calculate the height, because triangle is this we have to calculate. So this is DH, base we already have, we have to calculate GD, height of the thing. So GD is equal to DH into trim by LBP. So 11.500 into 3 divided by 171.87 is equal to 0.201 meters. Now put the area of triangle GDH is equal to 1 by 2 into base into height. So base is equal to DH into GD. Okay, so 1 by 2 into, put the value. So we get the area is 1.156 meter cube. Now volume of water wedge. Area of triangle GDH into breadth of the tank so is equal to 1.156 into 15, so we get 17.34 meter cube. Volume of water, so OBQ is onboard quantity is equal to observed volume of oil and water mixture minus volume of water wedge. Therefore 58.8 minus 17.34, so we get the value 41.46 meter cube on board quantity. Okay, so let's move the question number 5th. Question number 5th is a box shaped banker tank's dimension was 27 meter into 14 meter into 11 meter, was loaded at a 40 degrees temperature to 96% of its capacity. 96% of its capacity. With fuel oil density as 15 degrees centigrade in vacuum is 0.8825 tons meter cube. If this fuel oil is heated to 50 degrees centigrade, so initially it was 40 degree, now if heated it will become 50 degrees centigrade, then 20% by volume of the bunker are used. Okay, calculate the ullage shown by the tank radar. Okay, so radar gauge fitted 5 meter forward, the location of the radar forward, after bulkhead 3 meter to port of the center line and 1.5 meter above the deck. If the vessel is trimmed 4.19 meter by stern, listed 2 degrees to starboard, LBP is 200 degree. So we have to calculate. So first we have to draw the diagram. Okay, so volume of tank is equal to length into breadth into height is equal to 27 into 14 into 11 is equal to 4158 meter cube. Now gross observed volume at 40 degrees centigrade is equal to 4158 into 96 divided by 100, because it's 96% of its capacity, so we have to calculate the 96%. So calculation after 3991.68 meter cube. VCF at 40 degree temperature is 0.9812. So net absorbed volume at 15 degree centigrade is equal to 3991.68 into 0.9812, because GOV into VCF. So we get 3916.63 meter cube. This is at net absorbed volume at 50 degree centigrade. Now we have to convert this is on 50 degree centigrade. So VCF, we have to calculate the VCF at 50 degree centigrade. So 0.9738 we get, this is from Astem table 54. Okay, so now GOV at 50 degree centigrade is equal to 3916.63 is standard at this one, divide by VCF at 50 degree centigrade. So we get gross absorbed volume at 50 degree centigrade equal to 4022.01 meter cube. Now since 20% used, the remaining in tank 80%. So gross absorbed volume at 50 degree centigrade is equal to 4022.01 into 80 divided by 100 is equal to 3217.6 meter cube. Okay, so we have gross absorbed, we can find the sounding. So 3217.6 divided by length into breadth is equal to 3217.6 divided by 27 into 14. So we get 8.512 meter. Now sounding is equal to total height is ullage. So sounding is equal to total height minus ullage. .512 is equal to 11 plus 1.5 minus corrected ullage. Therefore corrected ullage is equal to 12.5 minus 8.512 is equal to 3.988 meters. Now we put this value in the formula. So ullage corrected for trim and list UT, so it's equal to UP plus L by 2 minus A into trim by LBP plus minus B into 10 theta. So UP is equal to ullage corrected for trim and list UT minus L by 2 minus A into trim by LVP plus B into 10 theta. So 3.988 minus 27 by 2 minus 5 into 4.19 divided by 200 plus 3 into 10 2 degree. So it's equal to 3.988 minus 0.178 plus 0.105 is equal to 3.915 meters. So observed ullage by tank radar 3.915 meters. An oil tanker of length between perpendicular 200 meter has a box shaped tank of dimension length 40 meter, breadth 20 meter and depth 20 meter and is loaded with oil. On completion, ullage as measured from ultrasonic tape, that means UTI wala formula, was observed to be 1.28, observed ullage 1.28 and temperature was 40 degrees centigrade. Water deep is also given 20.94 was also found. The ullage port was located, the location of ullage was given 1.1 above the tank top and 1.6 meter forward of the aft bulkhead. Vessel was trimmed 3 meter by Astem. Terminal give the density of oil is 15 degree temperature 0.845 tons per meter cube. Determine the quantity of oil in the tank on board tank. Quantity of oil. Okay. So how we approach this question? First we have to calculate the total quantity, mixture of oil and water. Then we have to calculate the water and then remove from the finals to water and we get the quantity of oil. So let's proceed to this question. So vessel trimmed by Astem. So ullage corrected for tape and trim. So here we use the ultrasonic tape, first formula, and in exam you have to write whatever given in the questions, okay, as I described in the question number 1. So follow that procedure for the better representation on the examination. So formula is equal to UO into sec into 10 inverse trim by LBP plus minus trim formula L by 2 minus A trim by LBP plus minus B tan theta, the list formula. So put the value 1.28 into sec 10 inverse 3 divided by 200 LBP. So trim by Astem and we have the ullage port location also as Astem side. So plus now 40 divided by 2 minus 1.6 into trim and divided by LBP. Okay, so we don't have the list, so we don't no need to list form. So 1.28 plus 0.276 is equal to 1.556 is corrected away. So depth of mixture, so this is, we find out this ullage, but oil or water mixture is here, so we have to find this value. So depth of mixture is equal to height of top of the ullage 5 to the tank bottom minus corrected ullage. So therefore 21.1 minus 1.556 is equal to 19.544 meters. So gross observed volume of mixture of oil length into breadth of the tank into the depth of the mixture. So 40 into 20 into 19.544, we get the mixture quantity 156352 meter cube. Okay, so we get the total quantity mixture of oil and water. Now we have to remove the water, so we have to use Wedge formula. A, B, C, D. Okay, so we have UO 20.94, UP 21.1 meter given in the question, Ullage pipe above the tank top, so this height 1.1 meter, A is equal to 1.6 meter, forward of the aft bulkhead, so UT is equal to UO into sec tan inverse trim by LBP. So 20.94 into sec tan inverse 3 divided by LBP 200, which is get the value to T.942 meters. Now TP is equal to UP minus UT, correct? So 21.1 minus 20.942, we get 0.158 meters. Find out the value of pH. pH is equal to TP into LBP by trim. So therefore 0.158 into 200 divided by 3 is equal to 10.533 meters. So DH is equal to A plus pH. A is equal to 1.6 plus 10.533 is pH. So we get 12.133 meters. So if DH is less than CD, so DH we have 12.133 and CD we have 40 meters. So that means DH is less than CD, so wedge is formed. Now we have to find out the height. GD is equal to DH into trim by LBP is equal to 12.133 into 3 divided by 200, so we get a 0.182 meters. Now find out the area of the wedge. 1 by 2 base into I, base is equal to DH into GD is equal to 1.2 into 0.182 into 12.133. So we get area of triangle GDH is equal to 1.104 meter square. Now volume of water, area of triangle GDH into breadth of the tank. So 1.104 into 20, so we get the value 20.1 meter cube. So total observed volume, we get observed volume of oil is equal to total mixture of oil and water minus volume of water. So 11.15 15635.2 minus 22.1, we get 15613.1 meter cube. Now we required quantity in tons. So VCF at 40 degrees centigrade from ASTM table we get 0.9782. Now we get net observed volume at 15 degrees centigrade is equal to, this is called gross observed volume. So GOV into VCF. So 15613.1 into 0.9782, 15272.7 meter cube. Now weight reduction factor is equal to specific gravity minus 0.0011. So given in the question 0.8145 minus 0.0011 is equal to 0.8134. Mass is equal to net absorbed volume at 15 degrees centigrade into weight reduction factor. So therefore 15272.7 into 0.8134. So we get the mass 12422.8 tons. Or you can say quantity of oil at 15 degrees centigrade. Okay, on completion of cargo at a temperature of sounding, the tank deep was observed to be 8 cm. So we have to calculate in the meters. The vessel was upright and trimmed 2.5 meter by stern. Dimension of the tank were 36 meter, 27 meter and 18 meter length, breadth and height. LBP was 270 meters. Calculate the onboard quantity OBQ given that sounding pipe was located 5 meter from the aft bulkhead and 0.9 meter above the deck. So given in the question, deep was 8 cm, vessel was upright, trim 2.5 meter by stern, tank dimension 36 into 27 into 18, length, breadth and height. LBP 270, location of sounding pipe 5 meter from the aft bulkhead, 0.9 meter above deck. So calculate OBQ. Okay. So 8 centimeter is very small. So that means we have to check the wedge formula. Okay. ABCD is dimension of the tanks. So GH. Okay, so OL is given 8 cm. We have to convert in the meters, so 0.08 meters. UP is 18.9. 18 meters height plus we have the 0.9 meter above the deck. So 18 plus 0.9, so become 18.9. Trim is given 2.5. A is given 5 meter, this A, from the aft bulkhead. So find out the UL, this one, and we have the OL. So we can find out this UO. So UL is equal to UP into sec tan inverse trim by LBP. Therefore 18.9 into sec tan inverse 2.5 divided by 270 to 18.901 meter. Now UO is equal to UL minus OL. So 18.901 minus 0.08 is equal to 18.821 meter. UT is equal to UO into sec tan inverse trim by LBP. Therefore 18.821 into sec tan inverse 2.5 divided by 270 is equal to 18.822 meters. So TP is equal to UP minus UT. 18.9 minus 18.822 is equal to 0.078 meter. pH is equal to TP into LBP divided by trim. So therefore 0.078 into 270 divided by trim 2.5, we get 8.424 meters. DH is equal to A plus pH. A is 5 and pH is 8.424. So we get 13.424 meters. So as DH is less than CD, because DH is 13.424 and CD is 36, so it is less than, so wedge is formed. So we have to find the height. Height is equal to DH into trim by LBP is equal to 13.424 into 2.5 divided by 270 is equal to 0.124 meter. Now find out the area of triangle. Area of triangle GDH is equal to 1 by 2 into GD into DH. So 1 by 2 into 0.124 into 13.424. So we get the 0.832 meter square. So volume of wedge. So volume of wedge is calculated only in volume, not in mass. So OBQ. Area of triangle GDH into breadth of the tank. So 0.832 into 27. So we get 22.46 meter cube on board quantity. Now let's move the next question. A box shaped tank 35 meter for 24.3 meter and 15 meter had 83 meter cube of ballast on arrival at the loading port on a ship of length between perpendiculars 219 meter. This tank was then loaded with 5000 meter cube of oil at 27 degrees centigrade. Density at 15 degrees centigrade in vacuum is 0.8193 tons per meter cube. And second cargo is 5000 metric ton of oil. Density in 15 degrees centigrade in vacuum is 0.8867 tons per meter cube. Calculate the final ullage by UTI gauge. Temperature was 12 degrees centigrade. Trim 0. Least 2.5 degree to port. The ullage port is located 6 meter forward of the bulkhead, 4 meter to port of the center line, and 88 centimeter above the top of the tanks. Okay, so this is little bit tricky question. It is not a tricky question, but we have to see how we have to calculate. Also, so we have to calculate this cargo one by one. So this all we have to bring in the meter cube so that we can find out the ullage. Okay, so let's proceed with question. we are solving the first cargo. So observed was given in the first is meter cube. So GOV is given at 27 degrees centigrade, 5000 meter cube. Okay, so VCF at 27 degrees centigrade is 0.9897. so we have to make it, bring it on 15 degrees centigrade. So GOV into VCF is equal to 5000 into 0.9897. So we get 4948.5 meter cube. Okay, now we require, this is on 12 degrees centigrade, so both we have to need to bring on the 12 degrees centigrade. So absorbed volume, or you can say GOV at 12 degrees centigrade is equal to net observed volume at 15 degrees centigrade divided by VCF at 12 degrees centigrade. So for that we have to calculate VCF at 12 degrees centigrade from ASTM tables. So we get 1.0026 from ASTM table 54. So put the value 4948.5 divided by 1.0026. So we get 4935.7 meter cube. Okay, so let's see the second parcel of cargo. Second cargo, it is given here metric tons, so we have to convert into the volume. So quantity of oil given in metric tons. Now weight reduction factor, now we are going to opposite, no? So 0.8867 minus 0.0011 specific gravity, no? So 0.8856 tons per meter cube. Specific gravity minus 0.0011. So net observed at 15 degrees centigrade. When we are calculating directly, so GOV, then VCF, the net observed volume is equal to GOV into VCF, and then weight reduction factor, and then mass is equal to net observed volume into weight reduction factor. So now we have mass, we have the weight reduction, we have to subtract, divide by this, so we get the net observed volume. So quantity of oil divided by weight reduction factor. So therefore 5000 divided by 0.8856, we get 5645.9 meter cube. This is on 50 degrees centigrade. Now we have to go in at 12 degrees centigrade. So VCF at 12 degrees centigrade from ASTM table we get 1.0022. Okay, so observed volume at 12 degrees centigrade, same again we have to divide. So we get 5645.9 divided by 1.0022, we get 5633.5 meter cube. Okay, so we have to add all the ballast and both the cargo. So total observed volume of oil, water mixture at 12 degrees centigrade. So first parcel of cargo plus second parcel of cargo plus ballast water. So 4935.7 plus 5633.5 plus 83. So we get 10652.2 meter cube. So depth of oil water mixture at 12 degrees centigrade is equal to total absorbed volume of oil mixture at 12 degrees centigrade divided by L, length into breadth. So 10652.2 divided by 35 into 24.3. So we get the sounding 12.525 meter. So corrected ullage of oil water mixture at 12 degrees centigrade, UT is equal to 15 plus 0.88 minus 12.525 is equal to 3.555 meter. Put the value in the formula. Ullage corrected for tape and list because no trim. So UT is equal to UO into sec tan inverse trim by LBP plus minus B tan theta. Therefore UO divided by cos tan inverse trim is 0, LBP is 219, okay, is equal to 3.555 plus 4 into 10 2.5. So we get the UO is equal to 3.355 minus 0.175. So UO is equal to 3.180 meter. So this is a Tamker's numerical for cheap made phase 1. So hope you understand all this numerical. Same question is given in the Martin sir notes. So if you this all already I explain. So thanks for watching. If you have a doubt, write me in comment box. We'll see you in next video with the past paper solution. Best of luck for your exams. Thank you.